is conservation of mass. So conservation of mass, if you remember before, after we make all our assumptions, basically what it says is the rho or the mass flow in equals the mass flow out. Here we have VA is our in, VB is our out. So we can say, and then we can simplify this more, our rows are the same, our densities are the same. So we can say rho, we can cancel those out. So all we're left with is VA AA equals VB AB. And we're being asked to find the pressure at A. So I'll show that in a second here. Um, so we know we're given VB here, and we can find the areas. So we know VB, we can find the areas of our cross section in both places. All we have left to find is VA. So to do that, we're going to have VA equals VB AB divided by AA, and I'll write it here. So AA, so the area at A equals pi d squared over 4, which equals pi times 120 over 1,000 squared over 4. And I did this here because I'm converting from millimeters to meters. So the area at A is going to be, let me take a look here. Should be about 0.0.01131 and then meters squared. Area at B is going to be, again, the same thing, pi d squared over 4 equals pi times 40 over 1,000 squared over 4. And then we get at AB 0.00126 meters squared. So if you plug those numbers in here, right, we're going to have VA equals VB, which we know is 4, given that. So equals 4 times AB, which is 0.00126 meters squared. And then this here is meters per second divided by 0.01131 meters squared. You should get a velocity of 0.444 meters per second. Okay. Now, let's use Bernoulli's, or, this kind of comes from our conservation of energy. So I'll erase this, I guess, and I'll just put Bernoulli's. I think that's how you spell it. So Bernoulli's is saying that uh, the energy on one side has to equal the energy on the other side. So PA over rho plus VA squared over 2, VA squared over 2 plus GZA equals PB over rho plus VB squared. VB squared over 2 plus GZB. So now we can make some simplifications. So we can set our datum to be at A. So this is our datum. which means z equals 0 here, and then this is our zb here, and z here is going to be equal to 0.5, and that's just 500 millimeters divided by 1,000 to get 0.5 meters. Okay, so ZA equals 0, ZB we can keep. If you remember from class, if we let our fluid flow out into the atmosphere, the pressure there is 0. So at PB, we're being let out into the atmosphere. So the pressure here is 0. And then here, PA equals some number that we don't know yet. That's what we're looking to find. But because PB equals 0, we can say, we can simplify this and say this is 0. So 0, 0. Let's see what we have left. So PA, we're looking to find. VA, we know. BB, we know. GZB, we know. So if we simplify this, the pressure at A becomes VB squared minus VA squared over 2 plus G times ZB. And then we're going to multiply this by rho, which comes from here, right? And if you plug in your numbers, right, VB was 4. So 4 squared is 16 minus 0.444 squared over 2 plus G, which is 9.81. Z was 0.5. And rho is 1,000. Plug all those numbers in, and you do the calculation. You should get around 12,806, give or take. It could be a little more, could be a little less, depending on how you rounded. But yeah, something around here. All right.